so I'm just going to run through this very quickly. So we use everything on the left here to, set up our circuits. And this is an example of a series circuit since there's one path for current to flow. And keep in mind, if I connect this circuit right now with no resistor or nothing to have a voltage drop across, look what will happen to the battery. It goes on fire. And why that we need something in there to take the voltage. So if I connect a wire here is the way my first setup should be. So this would be what figure 1 should look like. This has one light bulb. I can use my voltmeter and place it across the battery. Remember, it has to be connected in parallel, and I can change the voltage of my battery here. And then current, this is an ammeter. I can place this little bullseye over any point in the circuit, and it's 2.45 amps. No matter where I am in the circuit, the current does not change. Now, we are comparing the brightness of the bulbs. So if you notice that, let's add a bunch of light bulbs in here. Obviously, we're looking at 2 and 3, but if I want to jump right to the third one, again, there's still one path for current to flow. And now, as you see in series, as I keep adding light bulbs, the brightness of these bulbs goes down. Okay, so for the second part of this circuit, we're looking at parallel. And here, obviously, when we're looking at figure 4 in the diagram, we're just going from the battery to the light bulb and back into the battery. And here, basically, it's a series circuit. We can hook up our voltmeter again. Now, to add something in parallel, we are going to split the current. So obviously current can't flow unless it's a closed path. So I'm going to set up another light bulb here. Let me move that. And as you can see, as I'm adding light bulbs in parallel, the brightness does not change, which is very, very important and very helpful to note. Now, if I take my ammeter and I look at the current near the battery, it's 4.9. So as we add light bulbs or resistors in parallel, the total resistance goes down, meaning the total current goes up. And again, current's going to split. So here I have 4.9 amps of current, but as it splits, if I go here, it's less. So it'll be 2.45. And then it would also be that there. But the second I go close to the battery, I'm getting the total current in the circuit. So if I want to measure total current, I need to put the ammeter near the battery. And then I could hook up as many as I wanted. Again, this is in parallel. And you'll see that the brightness does not change. But as we keep adding these in parallel, the brightness stays the same, total resistance goes down, meaning the total current goes up.